Hi folks, welcome back to 6.1 video part 2. So we're going to look at actually using all the identities we learned in the last video to do something called verify identities. And basically when we have an identity, we have a right-hand side, we have a left-hand side, and it's going to be equal to a right-hand side. And our job is to use some algebra and some simplification and a lot of the identities we just learned to show that those two are actually equal. So we want to make this left-hand side equal to the right-hand side. Okay, let's get started. Example 1. Tangent squared times 1 plus cotangent squared equals 1 over 1 minus sine squared. And so what I'm going to do in this case is I'm going to start with the left-hand side, and I'm going to try and make it equal to the right-hand side using algebra and the identities that I learned above. And so let's get started here. I have tangent squared. And instead of 1 plus cotangent squared, I'm going to put cosecant squared. And the reason why I can do that is because this is a Pythagorean identity. Okay, so 1 plus cotangent squared, another way to say that is cosecant squared. So I can just make that substitution. Now I'm going to go ahead and take both terms on this side and I'm going to turn them into terms that involve sine and cosine. So tangent squared I can say is sine squared x divided by cosine squared x. And cosecant, I can say, is 1 over sine. So cosecant squared is 1 over sine squared x. And I want that to equal 1 over 1 minus sine squared x. Okay, now in looking at this left-hand side, I realize that I can cancel out the sine squared because 1 is on the top and 1 is on the bottom. And so what that gives me on the left-hand side is 1 over cosine squared x equals 1 over 1 minus sine squared x. Now we're going to use another Pythagorean identity to replace this cosine squared. And so that identity, we have one that says cosine squared x plus sine squared x equals 1. And look what happens if I subtract the sine squared from both sides. Cosine squared x equals 1 minus sine squared x. So that means everywhere I see a cosine squared, I can replace it with 1 minus sine squared. So this will give me 1 over 1 minus sine squared x equals 1 over 1 minus sine squared x. And since the left-hand side equals the right-hand side, I have verified this identity. Okay, let's move on to example number 2. Example number 2. I'm going to do something similar where I'm going to start with the left-hand side and I'm going to try and make it equal to the right-hand side. And the strategy that I want to focus on in this example is splitting fractions. And what I mean by splitting fractions is that if I have 1 minus x over 2, I could write that as 1/2 minus x over 2. So I've taken one fraction and I've split it into 2 separate fractions. And so we're going to do the same thing here with this left-hand side. my first fraction will become tangent x over sine x cosine x, minus my second fraction will be cotangent x over sine x cosine x, and I want to make that equal to secant squared x minus cosecant squared x. Okay, now I'm going to take the tangent and I'm going to rewrite it using sine and cosine, and I'm going to take the cotangent and also write that in terms of sine and cosine. So if I go back to my fraction, I know I have a sine x cosine x in the bottom, but instead of tangent, I'm going to write that as sine x over cosine x. So the purple comes from that tangent. Minus, leave space for what you're going to turn cotangent into, and we're going to turn cotangent into cosine x over sine x. So again, the blue ones come from cotangent. And we want to make this equal to secant squared x minus cosecant squared x. Okay, let's see if we can cancel anything. So sine and sine are going to go to 1 in the first fraction, and cosine and cosine are going to go to 1 in the second fraction. This makes my first fraction 1 over cosine squared x minus the second fraction as 1 over sine squared x equals, we hope, secant squared x minus cosecant squared x. Okay, we are almost there. 1 over cosine squared I can write as secant squared, minus 1 over sine squared I can write as cosecant squared x. And that is exactly what I have on the right-hand side. So these two sides are equal, and so we can say we have verified the identity. Okay, let's move on to example number 3. I have two very similar looking sides to my identity here, and just to show you that I can start with either side, I'm going to start with the right-hand side this time and try and make it look like the left-hand side. And the strategy that we're going to showcase in this example is conjugates. And some of you might say, oh, I've heard of conjugates before. I think probably the two main cases where you've seen conjugates are when you're doing complex conjugates with I. So, for example, 1 plus 2i and 1 minus 2i are complex conjugates. But we could also think about conjugates in terms of something with radicals, like x minus root 3 and x plus root 3 would be considered conjugate pairs. And so where we're going to use the conjugate is with this 1 plus sine. So the conjugate of 1 plus sine x is going to be 1 minus cosine x. And that's where we're going to start working with the right-hand side of our proof. So cosine x over 1 minus sine x equals 1 plus sine x over cosine x. Now I'm going to add an extra step in here just this one time so we see where this comes from. But I want to take this right-hand side and multiply it by 1. And what happens here is when I multiply by 1, I'm not really changing anything. So then that means that everything is still okay. But let's think about a fancier way that we could write 1. So cosine over 1 minus sine equals 1 plus sine x over cosine x times, let's use our conjugate, 1 minus sine x over 1 minus sine x. And that will give me a fancy way of saying 1 that will also help some things go away. Okay, so I'm going to say this. We're going to FOIL the top, but we're going to leave the bottom. So I'm going to leave the bottom as cosine x, 1 minus sine x. But the top, when I FOIL that, I'm going to get 1 minus sine squared x because the middle two terms drop out. Okay, where does this get me? If I go back a few problems, I might remember that 1 minus sine squared, I can write cosine squared instead of that. And that's exactly what I'm going to do here. I'm going to use a Pythagorean identity to replace the numerator of the right-hand side. And I will get cosine squared x over cosine x times 1 minus sine x. Okay, time to look for things that cancel. Well, I see one of my cosine on the top and the one on the bottom are going to cancel out. What does that leave us with? Well, our left-hand side has stayed the same the whole time, and now on the right-hand side, we have the exact same thing. So we have successfully verified this identity. Okay, we're going to go ahead and pause here for the second part of the video. Come back for the third part of the video for 6.1. See you there, folks.